Okay, these symmetry problems take 3 steps. First you have to plug it in right, then you actually have to show the algebra, and then you have to make the right conclusion. So for x-axis, remember we're trying to prove it. So the x-axis means that the y is going to be negated. So the first step is plug in the x is the same, the y is negative. So the x is the same, that doesn't do anything. But the y's, now every place there's a y, you're going to put a negative y. So that's going to become a negative y over 16 equals 1. That's the first step. The second step is showing that the negatives go away. Or don't, but here they will. A negative y squared turns it back to y squared. And now that's exactly the same, so now you can say yes. 3 steps. Plug it in, do the algebra, show the conclusion. For the for the y, this is when x changes. So we're going to need a negative x every place there is an x. So now it's negative x all squared over 9. The y's stay the same. Show the algebra. A negative x squared goes back to a positive x. And yes, it's exactly the same. For the origin, you change them both. So a negative x all squared over 9 plus a negative y all squared over 16. Sure enough, 2 negatives make it back to positive x squared. 2 negatives make it back to positive y squared. And that one is a yes. And then for the last one, you switch the order. So where there's an x, put a y. So x squared now becomes y squared over 9. Where there's a y, put an x squared over 16. Now there's really no algebra to do. It's basically already done. There's no negatives to fix, but the order of the numbers have changed. This is not the same as the original, so that one is not symmetric across the y equals x line.